So here we're going to calculate the derivative of y equals the square root of x squared plus 3. So the first step you want to do is to rewrite the equation, putting the square root into an exponential. I have colored the g of x function in red and the f of x function in purple. So when you're taking the derivative, it'll be the f prime of g of x times g prime of x, as stated by the chain rule. Next, you want to simplify down, and you get your end result. Here we're going to calculate the derivative of y equals 4 plus cosine of x cubed plus 2 all to the 10th power. So to solve this, we'll be using the chain rule. This is one way that the chain rule can be written. I have highlighted the parts of the equation as they show up for the chain rule. This is the derivative form of it. From here, we will simplify. The simplified equation equals y prime equals negative 30x squared times sine of x cubed plus 2 times 4 plus cosine of x cubed plus 2 all to the 9th power. Here, we're going to evaluate this integral. So to do that, we're going to use u substitution. To understand u substitution, you need to know that the integral is u prime times f of u dx, which is equivalent to the antiderivative of f, with the inside function being f of x plus c being some constant. So first we're going to say u equals x to the 4th, and du equals 4 times x cubed dx. Alright, now we're going to plug in u into the equation. Du replaces 4x cubed and dx. Next, we're going to find the integral of cosine of u, which is sine of u plus c, and then substitute back in the value for u, which is x to the 4th. And with that, you have evaluated the integral. Here, we're going to evaluate this integral. So we're going to evaluate it using u substitution, where u equals x cubed plus 1 and du equals 3 times x squared dx. Du can also be rewritten as 1/3 of du times x squared dx. So now we're going to plug these into the integral. You get the integral of 1/3 root u du, which can also be rewritten as 1/3 of the integral of u to the 1/2 du. Next, find the integral of u to the 1/2 multiplied by 1/3. From there, you can plug in the original value for u and simplify. C does not need to be multiplied by 1/3 because it is a constant.
F of x equals x squared plus 3, and g of x is the inverse of f of x. Find g prime of x. The first step is to find the inverse of f of x. This is done by isolating x. Therefore, x equals the square root of y minus 3. Then put it in terms of g of x. Therefore, g of x equals the square root of x minus 3. The next step is to find the derivative of f of x. The derivative of f of x is 2x. Finally, use the equation g prime of x equals 1 over f prime of g of x. Plug in 2 of x for f prime and g of x for x. Therefore, the inverse g prime of x equals 1 over 2 times the square root of x minus 3. This can be further simplified and rewritten to 1/2 times x minus 3 raised to the negative 1/2. Find g prime of the square root of 2 over 2 if g of x is the inverse of f of x equals cosine x. The first step is to find the inverse of f of x, which is g of x equals cosine inverse x. The next step is to find the derivative of g of x, which is negative 1 over the square root of 1 minus x squared. Next, plug in the square root of 2 over 2 for x in the function g prime of x. Continue to solve for g prime of the square root of 2 over 2 and simplify until you get negative 1 over 2 raised to the negative 1/2.
Evaluate an integral, the lower bound of 0 and an upper bound of 1. d of x over the square root of 1 minus x squared. First, you need to remember that the derivative of sine inverse of x equals 1 over the square root of 1 minus x squared. That means that the integral of dx over the square root of 1 minus x squared is sine inverse of x. Now remember your bounds. Sine inverse 1 minus sine inverse 0. You end up getting pi over 2 minus 0, which simplifies to pi over 2. The inverse of f of x is g of x. If f of x equals x minus 2 over 12, find the integral of g of x. So first, we're going to solve for x, knowing the values of f of x. We end up getting x equals 12y minus 2. Switch the values for x and y so that the equation 12x plus 2 is equal to g of x. Now we're going to find the integral of g of x dx. Plug in 12x plus 2 into the integral. Then simplify. 6x squared plus 2x plus c equals the integral of g of x dx.